Music is the universal language of mankind. Where words fail, music speaks. Life is like a beautiful melody, only the lyrics are messed up. Music in the soul can be heard by the universe. Music is the science that must have certain rules. They must be extracted from a self evident principle, which cannot be known without the help of mathematics. Musical fraction. Did you know that music is full of fractions? Music is made up of all sorts of rhythms, and each rhythm can be broken down into smaller pieces, measures which are fractions of rhythmic phrases, and beats, which are fractions of measures. Musicians must be able to count and subdivide rhythms in their head in order to play them, and this activity provides a tool to help early musicians learn how to count their own rhythms. Maths and music have always had very close relation. Music played a key role in the transition from whole numbers to rational ones. Despite Pythagoras had based his philosophy on integers and in particular on the first four numbers, tetractys, practicing the music for cathartic purposes. He discovered that the heights of the sounds were linked to each other by precise numerical ratios, a fundamental discovery enough to be immortalized in the saying that all is numbers rational. Tetractys is the sum of 10 identical objects arranged as an equilateral triangle was the figure most sacred to the Pythagoreans. The triangle had 4 points on each side and a point at the center or could be seen as a point on the highest level, just below 2, then 3 and finally 4. There is a quote by Pythagoras. There is geometry in the humming of the strings. There is music in the spacing of the spheres. Later on, Pythagoras built a primordial guitar, evaluation of the monochord, and studied the sounds produced by bungee cords made from ox nerves strained by different weights. He discovered that the consonants between pairs of sounds were repeated when these tensions were linked by a relationship of 1 is to 4 or 9 is to 4. The distance between these notes was the interval of an octave. We look at the mathematics associated with the guitar in rock music. Pythagoras, who analyzes the length of the sides of the right angle triangles, worked on a lot of other mathematical ideas, including working out how long guitar strings need to be to create certain notes. He found that mathematically, the note's pitch is inversely proportional to the length of the string. As can be seen in this diagram, Pythagoras worked out in ancient times that using frets to change the string lengths into certain fractions of the full length resulted in certain pleasant sounding musical notes. These Pythagoras fractions values are still used today when making guitars. Musical scales are related to Fibonacci numbers. The Fibonacci series appears in the foundation of aspects of art, beauty, and life. Even music has a foundation in the series. as there are 13 notes in the span of any note through its octave. A scale is composed of 8 notes, of which the fifth and third notes create the basic foundation of all chords and are based on a tone which are combination of two steps and one step from the root tone, that is the first note of the scale. Musical compositions often reflect Fibonacci numbers and pi. Fibonacci and pi relationships are often found in the timing of musical compositions. As an example, the climax of songs is often found at roughly the pi point, that is 61.8% of the song, as opposed to the middle or end of the song. In the 32-bar song, this would occur in the 20th bar. How is it that Beethoven, who is celebrated as one of the most significant composers of all time, wrote many of his most beloved songs while going deaf? The answer lies in the math behind his music. Natalia St. Clair employs the Moonlight Sonata to illustrate the way Beethoven was able to convey emotion and creativity using the certainty of mathematics. Musical instrument design is often based on phi, the golden ratio. Now let's hear the amazing music of pi.